In our today's mathematics class, we are going to look at understanding fractions, decimals, and percentages. Understanding fractions, decimals, and percentages. But before we go into that briefly, we need to understand that fractions were used long ago in the ancient Egypt times. That's about 4,000 years ago. And the Egyptians, in this case, they actually had a sky god whom they called Horus. Horus was an Egyptian sky god and was a falcon-headed man whose eyes, that is the Egyptian sky god, was called Horus and was a falcon-headed man whose eyes were believed to have magical healing power. So the Egyptians used jewelry, ornaments, or clothing which were decorated with Horus design, were actually regarded as good luck, charms for health. So those decorations that they decorated their god were regarded as good luck charms for health, and the magical predictions from evil. Now, what is so special about this, the Horus god? It is not the powers the god held. It is not the magical predictions from evil that the Horus had, but I want us to look at the 6 parts in the eye. In the eye of a Horus, in the eyes of a Horus, there were designs which represented 6 ways. And that was the way of getting information into the brain. Those 6 ways were the way that were used to get the information into the brains. Now, how was this information given into the brains? The 6 different parts, or symbols represented 6 fractions which were used by ancient Egypt. So we are seeing that in the eyes we had 6 symbols. And these 6 symbols represented 6 fractions which were used in the ancient Egypt. Now, among those fractions that we have, as you shall see them on the charts that were used by the Egyptians. Now, looking at our chart here, we have got symbols or signs which may not make sense, but to the Egyptians, they made a lot of sense. They gave a lot of information. The first sign, which is a thought eyebrow closest to the brain. If you look at the eyebrow, it is normally almost similar to this shape. It represented an 8th or 1/8. So if you wanted to denote 1/8 in Egyptian, we use an eyebrow. This other one, this side here, meant 1/16, which meant hearing and pointing to the ear. So wherever you saw this, the information was asking the Egyptian that this information is to be heard, because the sign points to the ear. This other one meant a half, where a half is for the smell, pointing to the nose. The one like a circle is a quarter. And to the Egyptian, it is a sight. So sight, in this case, the pupil of the eye. So it was represented by a quarter or this circle there. This other sign here stands for 1/64, which meant a touch. And the sign in itself was like a leg touching the ground, but it stood for 1/64. Then we have a coil or a curled top here, which stood for 1/32, which is a fraction, and it meant test. Curled top of wheat plant. The way it looks like, it's a curled top of wheat plant. If you have seen a wheat plant, in a wheat plantation, the top of a wheat is curled almost like this. So you notice that all these are fractions. But the fractions here are represented in form of shapes. Now, you'll notice that from the shapes that we have here, we can take a portion of fraction and write using combination of this symbol. For example, what do we do if we want to represent 3/4? 3/4 is a fraction, and we want to represent it. In ordinary mathematics situation, 3/4, these are 3/4, or it's a half plus a quarter. So we look at combination of the shapes that will give us something similar to that. So you'll notice that for this to represent 3/4, first we shall take a half. A half is this sign here. The sign looks like this. That sign is a half, which is the same as 2/4. And then we look for a sign which has a quarter. So, and a quarter is like this. So we have combination of two symbols, and the two symbols here represents 3/4. Supposing we want to find out 3/16. Using the symbols. What we have here is 1/16. We have a half, we have a quarter, we have an eighth. So to represent 3/16, we need to find out. What do we need? When you look at an eighth is equivalent to 2/16. So we shall require an eighth that is equivalent to 2/16. And then we add 1/16, which is this way. So when you look at this, the two signs, this sign here is right here, which is 1/8. A mathematician will notice that 1/8 is equivalent to 2/16. Let's see. 2/16, this is what you're having here, plus 1/16. I said 1/8 is equivalent to this because by 2, 1 by 2, 8. So when you bring the sign that represents 1 over 8, which is this one here, it will simply give us 2 over 16. Then plus 1 over 16, you get a combination of the two signs. Let's see which symbols would represent 7 over 8. Which symbols would represent 7 over 8? Now, we have all symbols here, but when you look at 7 over 8, it's not there. We have got 1 over 8. Shall we going to have this sign 8 times? Will it be giving us what we require? So we need to relate others and see. You notice if we take, for example, 7 over 8, we require, if we take a half and compare it to 7, 1 over 2, this one is the same as, when you want to have the denominator as 8, it will be 8 divided by 2 times 1, which is 4 over 8. Then it means that where we have a half, we shall have already taken care of 4 over 8. From 7, we remain with 3. Now, when you look at 3 over 8, 3 over 8 will mean that we go for one which will give us 2 over 8, and 2 over 8, you'll realize that 2 over 8 is the same as a quarter. And a quarter in this particular case, you'll notice that a quarter is represented by this circle. So if we put a quarter there, we have actually shown 2 over 8. So the sign here is for a quarter, so instead we shall take care of the quarter here. This one we have agreed is a half. And what remains is 1 over 8, which is straight there. So a half is shown by this sign. So we want to say that 7 over 8 will be equal to a half, which is this. So we bring the half sign here. The next is a quarter, and a quarter is here. And then the last one is 1 over 8, and 1 over 8 is up here. So we shall do like that. So the combination of these three symbols gives us 7 over 8. They are giving us 7 over 8. Now, let us come to factors and multiples. Factors and multiples are key building blocks for broad field that is known as number theory. We need these factors, we need these multiples for us to understand the broad blocks of the building blocks of the broad field of number theory. Now, let us look at the concepts of factors and multiples. I want us to consider this statement. We may have, I know we all know what donuts are. Now, let us take it like we have a dozen of donuts inside a box. This is my box. Inside we have a dozen of donuts. You all know a dozen means 12. And it's arranged in a row of 4 and a column of 3. So in this pack of 12 dozen, you realize that we have got, there are 3 arrangements, each row having 4, but 3 times. So I want to say that there are 3 rows and 4 columns of the donuts. 3 rows by 4 columns. So to get the total number of donuts in this pack, shall say it is 12. So if that is the case, then we can say that 3 and 4 are factors of 12. 3 and 4 are factors of 12. Supposing you went ahead and purchased several packets or bags of dozens of donuts. You go and purchase a multiple packs of each pack of a dozen of donuts, then it will mean that you can have several. Someone can choose to buy maybe 1 pack, and a pack contains how many donuts? It contains a dozen of donuts, which is 12. Another one may choose to buy 2 packs, and 2 packs will mean that it contains 2 dozens or 2 of these, which is 24. If you settle to buy 3, then it will mean that whoever buys 3 packs of donuts then will have bought a total of 36 donuts. So you'll notice that it is increasing at any given time by 12. We have the first 12, 1 pack, 24, 2 packs, 36, 3 packs. If we were to move to the 4th pack, we would have 48. So if you choose to buy 4 packets, you'll have 48 donuts. These numbers, 12, 24, 36, and 48, they form what we call multiples of 12. They form what we call multiples of 12. Of a particular number are numbers. Are numbers that divide evenly into that number. Factors of a particular number are numbers that divide evenly into that number. And this is written in an ascending order. Factors are written in ascending order. Taking, for example, 12. Factors of 12 are 1, 2, 3, 4, 6, and 12. You'll notice that each of these number divides 12 evenly without a remainder. That's why we say they are factors. And the factor, we begin by the number itself is a factor, and 1 is always a factor of any given number. Because we said that when we have a factor, then product of factors should give us the number. Look, for example, we are saying 1 is a factor, but how do we get 12 given that 1 is one of the factors? It should be multiplied by another factor, which is what? Out of all these numbers, the only factor which will give us the value of 12 is 12. Two is also a factor because 12 is the same as 2 times 6 and not any other. So already 2 and 6 as a factor is covered. And 12 can also have 3 by 4 as its factors because the 2 can divide 12 evenly without the remainder. So factors of a number are always written in an ascending order. So from this you should notice this, that every whole number is a factor of itself. So irrespective of which number you are talking about. If I take 20, I'll know the first thing there is that it's a whole number, so it's already a factor of itself. That's why we are saying every whole number is a factor of itself. And also 1 is a factor of every whole number. So 1 is a factor of every whole number. And the whole number itself is a factor of its own. So there are those two numbers that will always apply in any given number. 1 is a factor of all numbers, and then the number itself that you are given. If you are given 13, then 13 is a factor. So a number is a factor of itself. So multiples of a particular number are numbers created by multiplying multiples of a particular number are numbers created by multiplying the particular number by any positive integer. So multiples of a particular number are numbers created by multiplying the particular number by any positive integer. For example, if you want to get multiples of 20, The first, when you multiply 20 by 1, it's 20. So multiple of 20 is 20 itself. Remember, we said by multiplying by any positive integer. Let us start from the least, which is 1. It will give us 20. If it was multiplied by 2, we would have 40, then 60, 80, 100, 120, and so on. If this is the case, then we can say that number of multiples of a number is infinite. That is infinite. It is endless because we could continue with 280, 480, and so on, 600. All those are multiples of 20. That's why we say there is infinite number of multiples. Therefore, it follows that factors are less than or equal to a particular number. We need to note this, that factors are less than, we shall look at that. We are saying that factors are less than or equal to a particular number being considered. Let us take one of the numbers and reconsider it and see, will it fulfill this point? List the factors of 3. So if you want to get the factors of 3, you'll find that the factors of 3 is 1 itself. 2 cannot divide 3, so it is 3. So number of factors of 3 are 2. So the number of factors are less than the number itself, because we have 2 numbers as the factors and 3 was the number we were considering. So we find that the number of factors is less than the number being considered. How about if we were to look at the factors of 2? The factors of 2 is 1 and 2. Here, we have 2 factors. The number being considered is 2. And that's why we are saying factors are less than. In this case, it is not less than or equal to. In our case, it is equal to. You are looking for the factors of 2. That's the number we are considering. And the number of factors we found are also 2. So that's why we say that factors are either less than or equal to the particular number that is being considered. For the multiples, it is different. Multiples multiples are greater than or equal to the number being considered. In most cases, as we saw earlier on, multiples of a number goes infinite. Taking, for example, a number like 5. If you are asked for the multiple of 5, then you'll find that the multiple will be 5 itself, then 10, 15, 20, 25, and so on. It is infinite. So it's not even 5 itself. It's more than 5. That's why we say it's either greater than or equal to. So how do we arrive at these multiples? How do we arrive at these multiples? I want us to look at the following problem and see how multiples and factors are calculated. Find the complete set of factors of A, 15, and B, 40. Find the complete set of factors of A, 15, and B, 40. In our solution, we are interested in finding the factors of 15. So we find that factors of 15 are, as we saw earlier, 1 is a factor of any number as long as it's a whole number when we are given. So 15 is a whole number, so we shall start from the list. R1, then we have 3, we have 5 and 15. 1, 3, 5, and 15. How do we agree that these are the factors? To explain this, you'll notice that for 1, it is easier to know that 1 multiplied by 15 gives us 15, which implies that 1 and 15 are both a pair of factors of 15. Also, 3 multiplied by 5 gives us 15. Again, it gives us a true statement that 3 and 5 form a pair of factors of 15. So we have the factors as 1, 3, 5, and 15 itself. For this other number, which is 40, factors of 40 are, the list is 1. So you go as it ascends. Another number that can divide 40 is 2. We have 4. We have 5, 8, 10, 20, and 40. These numbers, all of them, can divide 40 evenly without the remainder. Now, taking a combination of these factors, can they prove and give us exactly 40? So to explain this, we need to pick several pairs of the factors that we have and see if it will give us 40. Let us start with 1. 1 times a number gives us 40. Definitely that one is a 40. 1 times 40 is 40. So we've covered 2 factors. The other one we have is 2. 2 multiplied by what gives us 40? It is 20. So 2 is covered and 20 is also confirmed. Taking 4. 4 multiplied by what will give us 40? You will find that it is 10. This gives us 40. So 4 is a factor and 10 is a factor of 40. The 2 factors remaining is 5 multiplied by 8, and this one will give us 40. So we've confirmed 5 as well as 8 are both factors of 40. Supposing we took a number that is not a factor, would the work be done? How come we've only settled on this? Let us try out 7. Supposing one of you wrote 7 as a factor. Is it possible? Can 7 divide 40 and evenly without a remainder? You'll find that it is not possible, because we said factors are only those numbers which divides a number evenly. So 7 cannot. So let us look at listing of multiples. This one we were listing the factors. And remember that always list from the least number in ascending order, and the last factor will always be the number itself. Listing multiples. Question: write down the first 6 multiples of A. You have 11, and B, you have 35. Write down the first 6 multiples of 11 and 35. Let's start this time with B, where we have 35. So our solution, multiples of 35 are, the list is by itself. There is one is itself, which is 35. The next is 70. They want at least 6. 105, 140, 175, and then we have 210. 1, 2, 3, 4, 5, 6. Yeah. Now, these are the multiples of 35. Then how do we explain and how do we be sure that these are the factors? How are we getting them? Now you'll notice that the first multiple is always the number itself. So that's why we started with that 5, and what we have there is that 5. The first multiple is always the given number. Now on that, you'll keep on adding the given number to the next multiple. If we had been given 35 as our first multiple, the number we are considering is that 5, we find that the first multiple is the number itself, which is that 5. So to get the next multiple, you take the number that you are given and add to the multiple you had. So to get the next multiple, it is 35 plus the number you are considering, which is 35, you get 70. That is the second multiple. To get the next multiple, you will take 70 where you are, add the number you are considering, which is 35, you will get 105, and 105 is the third multiple. So how are we getting multiples here? Let us note this down. These multiples, how they are being generated, is add on the given number, add on the given number to find the next multiple. To find the next multiple. And this process will always be repeated. So you keep on repeating the process. You repeat the process until you reach the 6th. That's why we took that 5, add that 5, you got 70. Take 70, add that 5, you get 105. So the procedure is repeating. Let us look at 11. So the multiples of 11 are, we start by the number itself that we are considering, so it is 11. Using what we've been told here, adding on the given number, so 11, add 11, you get 22. Add 11 to 22, you get 33. Add 11 to 33, you get 44. Add 11 to 44, you'll get 55. If you add 11, you get 66. They want the first 6. 1, 2, 3, 4, 5, 6. And to explain this again, we shall look at this. We are only adding the given number to the next, together again to the next multiple, and we keep on repeating the process until we arrive at what we have. Finding factors. Express 195 as a product of two factors. Both of which are greater than 10. Express 195 as a product of two factors, both of which are greater than 10. In our solution, we are guided by this statement: the factors are greater than 10. So I don't expect you to come and say one of the factors of 195 is 1. Yes, it is 1. But is 1 greater than 10? No. So forget. Another one says also, I think we have another number. Which number is that? I think 3 is also a factor of 195. Fine, but is 3 greater than 10? No. So we again cancel it out. Come to 5. It is true it's a factor of 195, but it is not less than 10. So there are key words that we normally look at. And that's why now here, as you list your factors, you will be looking for those factors which are greater than 10. And you'll find that the factors of 195, the 1, 2 factors, you'll find that we have 13 multiplied by 15. Why have I said 13 multiplied by 15? They are asking, express 195 as a product of 2 factors. So we shall take 2 factors, and those 2 factors must be greater than 10. And that's why we have 13 multiplied by 15. So in our explanation here, you systematically divide 195 by numbers. Systematically divide 195 by numbers greater than 10. In an attempt to get larger factor. Systematically divide 195 by numbers greater than 10. So they could use it several attempts. That's why we have called it, it's an attempt. In an attempt to get the larger factor. So we should be guided by the keywords in our question as we tackle this particular problem. As you go about the issue of factors, the issue of multiples, it is good to note of other numbers that exist, that I'll explain. We have other numbers that exist that we call even numbers. Odd numbers and prime numbers. Now, we should know what even numbers are. Even numbers are all the numbers that are divisible by 2. Even numbers are all numbers divisible by 2 or ends with a 0 or ends with either a 0, ends with either a 0 or a number that is divisible by 2. Then you shall say that number is even. For example, is 42 an even number? Looking at this, does this number end with 0? No. Does the number we have here divisible by 2? Yes. Or is the last digit, does the last digit end? The last digit at the end, is it divisible by 2? You'll find that the last digit, which is 2, is divisible by 2 evenly without a remainder. So 42 is even number. Looking at others, we've said which ends with a 0. Here, it can be a number like 30. 30 ends with a 0. And when you divide 30 by 2, you'll find that it will give us 15. So it divides without any remainders. That is an even number. So even numbers can be easily identified. So question comes. List 4 numbers, 4 even numbers between 50 and 60. So they want even numbers only that fall in between. So you'll find that 50 by itself ends with 0, so 50 is an even number. Another one should end with either a 2 or a number divisible by 2. So we have 52 is another even number. 54 is another even number. 56, 58, and 60 itself. All these are numbers that are divisible by 2. All these numbers, the last digit ends with either 0 or ends with a number divisible by 2, and that's why we say they are even numbers. Let us come to the odd numbers. Odd numbers. These are numbers they are numbers that are not evenly divisible by 2. Or whenever you divide by 2, there is always a remainder. And example of these numbers are numbers like, we have a number like 3, 5, 7, we have 9, 11, so even numbers are those numbers that they are those numbers when you divide by 2, you'll always find that there is a remainder. That's why we find that we don't have 2 here, but we have a 3. So 3, 5, 7, and so on, these ones are odd numbers. Odd numbers are those numbers which are not, when we divide by 2, they are not evenly divisible, but they have a remainder. This is the example of odd numbers. The last group is prime numbers. Now for prime numbers, we've seen issue about factors of a number. Now, how do we tell that a number is a prime number? We say that prime numbers have only 2 factors. And the factors are 1 and itself. So no other number can divide a prime number. Examples of prime numbers is 2. 2 can be divided by 2. So 2 by 2 is 1, and 2 by 1 is 2. There are only 2 factors. So when you want to list factors of 2, you'll find it is 1 and 2. Another number with strictly 2 factors is also a prime number. That number is 3. 3 factors of 3 is only 1 and 3. Another prime number is 5, which is 1 and 5. Then the question comes, is 9 a prime number or an odd number? 9. So we shall ask ourselves, how many factors are there for 9? 9 is divisible by 1, 9 is divisible by 3, and 9 is divisible by 9. So there are 3 factors of 9. Therefore, 9 that we have here is not a prime number. Prime numbers will only be divisible by 2 factors. A good example again of a prime number, we are still looking at a few examples of prime numbers, are numbers like 17, 23, 29. You'll notice that if I ask you to list down factors of 17, you'll find that 17 can only be divided by 1 and 17 itself. All the numbers in between here will never and cannot divide 17 evenly. Therefore, because they have 2 factors, then 17 is regarded as a prime number. List all prime numbers between 30 and 40. Between 30 and 40. Our solution here, we start by looking at 30 itself. We can list all of them and then we work out 31, 32, 33, 34, 35, 36, 37, 38, 39, and 40. So the knowledge behind here is an attempt to find if the number we have has got only 2 factors. So we start by looking at 30. How many factors are there? If it's more than 1, more than 2, we forget. 30 multiple of 30 has got factors as 1 is a factor of 30, 2, 5, and so on. So 30 is out. Then 31. Which other numbers can divide 31? You'll find that 31 is divisible by 1. It's not divisible by 2, neither by 3, neither by 4, or 5, or 6, or 7, 8, and so on. So it is only 1 and 31. So 31 is a prime number. 32 is not, because there is already 2. This is divisible by 11 and divisible by 3. It is not. 34 is not because of 1, 2, and 17. 35 is not because 1, 5, and so on. 36 is already an even number. It cannot. We have 37. 37 is a prime number because it is divisible by only 1 and 37 itself. 38 is not, 39 is not, and 40 is not. How do we arrive at identifying the 2? We attempt to list the factors of each, and if we find a number has 2 factors, then that number is taken to be a prime number. So let us look at this exercise. Fill the gaps. To complete the set of factors, fill the gaps to complete the set of factors for each of the following numbers. One, 18. 72. 'That's what we have. Let us look at those. So we are supposed to fill the gaps to complete the set of factors. The key word here is factors for the following numbers. First, the first number is 18, and they have stated for us the factors of 18. It is 1, 2, and then we don't know what follows here. We look for another number list which follows 2 that is divisible by 18. We'll find that it is 3, and then we have 6, then 9. After 9, the last one is 18 itself. For this other part, 72, it starts by 1, then 2, then 3. You'll also find that 4 is divisible by 72. We have another number, I think it's 6. 6 is also divisible. When you divide 6 by this, you'll find that you'll get 12. Then we have 12 here. So we have 9 before 12. We have 9, and then we have 12. So for us to be able to fill the gaps, it's an attempt to find the next number that can divide the number you have been given evenly without the remainder. By that, we come to the end of our lesson today. In our next class, we shall be looking at highest common factor and lowest common multiple. Thank you.